Figure 5 shows a sketch of part of the curve C with this equation, and the finite region R is bounded by the curve, the line with equation x equals 1 and the x-axis. We're asked to find the exact area of R, giving our answer in this form, where a and b are rational numbers. So we want to find the integral from 0 to 1 of 8x squared e to the minus 3x. So which integration method to use? Because we have like an x or a function like x squared or x cubed or something times a function that we know how to differentiate. This is all about integration by parts here. No substitution. We can't just go, it's not like reverse chain or anything. It's got to be integration by parts. In fact, it's going to be integration by parts twice because when I differentiate this, I'm going to get 16x and that will end up being in a second integral. So if you can spot that, you're already kind of halfway there. Okay, so I'm going to say, here's my formula. This is, of course, is derived from the product rule, but I'm going to call this one U, and then this one is going to be V dash, because then when I substitute it in here, it gets more simple. Whereas if it was the other way around, it'd get more complicated. And actually, there's a little way to remember it. It's late. So you always, well, I mean, it's just a little guideline really, but if you got a log in there, that becomes your U. Like if you're integrating ln x or x ln x, then it's algebra. And so that's what we're doing here, that the 8x squared, the exponentials all the way down here. So U dash is going to equal 16x, and then V is going to be the integral of e to the minus 3x. That's going to be minus a third e to the minus 3x. And then I will get uv, so that will be minus 8 over 3 x squared e to the minus 3x, evaluated between 0 and 1, minus the integral from 0 to 1 of minus 16 over 3. Well, that's going to become a plus 16 over 3 because there's a double negative, and then x e to the minus 3x. Now you can either keep going with all the integrations and deal with the definite part at the end, or I think in this case, I'm just going to work out the left-hand term. It's going to become minus 8 over 3 times 1 squared times e to the minus 3. And then when I substitute the 0 in, I'm just going to get 0. So that bit's sorted. And now I'm going to bring the 16 over 3 out, just to make it a little bit simpler. Okay, and we're one step through our integration. So I'm going to ignore now the 16 over 3, bring it back in at the end, and just work out the answer to this. X is going to be u again, e to the minus 3x is going to be v dash. So this time I get u dash equals 1. Brilliant, more simple again. And v is going to be minus a third e to the minus 3x. So let me call this like star or something. So star will then equal uv, so that's minus a third x e to the minus 3x evaluated between 0 and 1 minus the integral of, again, the u dash. So that would just be minus a third, which I can again change to a plus. So a third e to the minus 3x dx. Substitute the 1 in, minus a third e to the minus 3. And again, when I put the 0 in, I don't get anything. And then over here, I'm going to get minus 1 over 9 e to the minus 3x. Sorry, I forgot to put the limits in, evaluated between 0 and 1. Then over here, I'm going to get minus 1 over 9 e to the minus 3. And then I'm going to be minusing 1 over 9 e to the 0. And that becomes plus 1 over 9, because e to the 0 is just 1, and I've got this double negative going on. If you're not happy with that, remember this is a bracket, and I've got a negative there, and then I've just expanded the bracket. So before I put it in, let's just simplify this. It's going to be minus 4 over 9, because minus, like 1/3 is 3 over 9. So minus 4 over 9 e to the minus 3 plus 1 over 9. And I'm ready to put it back in. So therefore, the area is going to equal minus 8 over 3 e to the minus 3 plus 16 over 3 times this minus 4 over 9 e to the minus 3 plus 1 over 9. That is going to give me minus 8 over 3 e to the minus 3 minus 64 over 27 e to the minus 3 plus 16 over 27. And it's probably time to reach for the calculator. We've got the 16 over 27. We'll leave that as it is. And then just on your calculator, ignore the e to the minus 3 and do the minus 8 over 3, then minus 64 over 27. It'd be minus 136 over 27 lots of e to the minus 3. And that is our exact area, and it's in the form required here.